Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss a new problem on graph, that is the 0 1 matrix, right? So in this problem we are given a binary matrix of m cross n size and we have to return the distance of the nearest 0 for each cell, right? So what we are given a binary matrix, which means that only zeros and ones are present in this matrix, right? So in the given matrix only zeros and ones present, right? So let's take the example of this matrix. Also it is given that the distance between two adjacent cells is 1, right? So distance between these two is 1, distance between these two is 1, distance between these two is also 1, right? Distance between these two is 1 and 1, right? So distance between this 0 and this 1 is 2, right? So we have to find the distance of nearest 0 for each cell. This means that we have to traverse the entire matrix, right? So let's move to this cell, right? Now we have to find the nearest 0. Now the nearest 0 of this cell is this 0 itself, right? So the answer for this cell must be 0. Now, why? Because we have to find the nearest 0. Now this cell is 0 itself. So the nearest 0 is, distance is 0, 0, right? So the answer for all the zeros is 0. That is the distance between the nearest 0 of all the zeros is 0, because the nearest zeros are the zeros itself, themselves, right? So here also the nearest 0 is this 0 only, so the distance is 0. For this also, for this also, for this also, right? So the answer for all the zeros must be 0, right? So we have to find the answer for ones only, right? So let's find the answer for this one. Now the nearest 0 of this one is, can be this, this or this. All these zeros are present at the same distance. Now distance between the two adjacent cells is 1. This means that the distance of nearest 0 for this one is 1, right? Next, let's find for this one. Now the nearest 0 for this one is this. The distance between these two cells is 1. So the answer for this is also 1. Next, the nearest 0 for this one is this 0, right? The distance between these two cells is 1. So the answer for this is also 1. Now let's find the distance for this one. This, right? Now the nearest 0 from this one is either this 0 or this 0. These two are present at the same distance from this cell, right? So this is present here. We can move like this, like this, like this, or like this, right? So for all the parts, the distance is 1 plus 1, right? Here also 1 plus 1, here also 1 plus 1, here also 1 plus 1. So the minimum distance is 2, right? So the nearest 0 from this one is present at a distance of 2, right? So we have to return this matrix, that is we have to find the distance of nearest 0 for each cell. Now we identified that the distance for all the zeros must be 0, right? So we have to find the distance for ones only, right? So we are going to traverse this matrix. When we find a 1, we have to find the answer, right? So what we can do, we can move in all the 4 directions, right? So we can use BFS, right? Breadth first search, right? So for this one, firstly for level 1, since BFS is applied on level, so for level 1, if we find a 0 in any of the directions, then that level is the answer for this one, right? So firstly we apply BFS on this level, on level 1. So here we find a 0 in level 1, so answer for this is 1. Next, right? Next for this one, when we apply BFS on level 1, we find a 0. So the answer for this one is also 1, right? Because we find a 0 in the first level of BFS, right? Here also the first level, when we apply BFS on first level, we find a 1, we find a 0, right? So the answer for this cell is also 1. Now for this one, when we apply BFS on the first level, we haven't find any 0, right? So we have to apply BFS on second level, right? When we apply BFS on second level, we find the 0. So the answer for this is 2. So whatever will be the level of BFS, if we find a 0 on that level must be the answer for that cell, right? So we have to apply BFS on each cell with which contain a 1, right? So the time complexity of this approach will be what? The number of ones, right? Into the complexity of BFS, that is big O V plus C, right? So the time complexity of this will be this, that is the number of ones into the time complexity of BFS. So is there any better approach present for this? Yes, there is. What is that approach? In that approach also we are going to use the BFS, right? We are doing what? We are going to use a queue and we will store the location of all the zeros in that queue, right? So these are the rows number and these are the column numbers, right? So let's traverse in this matrix. Since 0 is present here, so store this location, that is 0 0. Store the location of next 0, that is 0 1. Store the location of next 0, that is 0 2. Store the location of next 0, that is 1 0. The next 0 is present at 1 2, right? So store all these locations in a queue, right? Next, mark all the unvisited cells where 0 is not present to mark all the unvisited cells. Now we can either mark this by using Boolean array, right? Or we can simply mark these ones to -1. These -1 indicates that these cells are unvisited for now, right? So we have to do what? We have to apply BFS on all these locations, right? Firstly, we are going to apply BFS on this 0, right? So when we apply BFS, we will check if any unvisited cell is present here or not on this level of BFS or not. Since no unvisited cell is present here, so we'll move to the next cell, right? So we'll move here. Here we will check if any unvisited cell is present on this. So apply BFS. Since one unvisited cell is present here, so this 0 will help to fill this unvisited cell, right? So how? By adding 1 to its value, right? So 0 will add 1 to its value and update the value of this unvisited cell to that value, right? So this will update to 1 because 0 plus 1 is 1, right? Now no other unvisited cell is present for this 0, right? So we'll move to the next 0, right? Now we'll move to the next one. Also, when we update any of these cells, we have to store this location also, right? Why? Because it can be possible that this one will help to fill any of these unvisited cells, right? By adding 1 to its value, right? So we have to store the location of this cell also, right? Next, we'll move 0 to no unvisited cell is present in the neighbor of this, right? So remove this. Next we'll move to 1 0. Now one unvisited cell is present in this for this 0. Now this 0 will help to visit that unvisited cell by adding 1 to its value, right? Now 0 plus 1 is 1, so this cell is updated to 1, right? So this value is updated to 1. This is also 1. Now after updating this value, add this location also because it can be possible that this 1 will help to fill any of the unvisited cells, right? Next we move to the 1 0. Also one unvisited cell is present in the neighbor of this 0, right? So this 0 will help to fill this visit cell by adding 1 to its value. This cell is updated to 1 and add this location to the queue, right? So we have visited, we apply BFS to the 0. Now is 1 2 1 2. Firstly it is 1 0. Now we have done it for 1 2 also, right? So we can see that all the ones present at a location at a distance of 1 from all the nearest zeros are done now, right? Are filled now, right? We have found the distance of all the ones which are present at a distance of 1 from the nearest zero, right? So it can said that only the ones which are present at a distance of more than 1 are left out now, right? So we'll move to 1 1. Now at 1 1 we are going to apply BFS. So when BFS is applied to this, let me change the pen color. So when BFS is applied to this, one unvisited cell is there, right? So one will help to fill this unvisited cell by adding 1 to its value. So this value becomes 2. So this 1 is updated to 2, right? And add this to the queue, right? So now this 1 1 is visited. Now we'll move to 2 0. In the neighbor of 2 0, all the cells are visited. In the neighbor of 2 2 also all the cells are visited. In the neighbor of 2 1 also all the cells are visited, right? So now our queue is empty. We have visited all the cells and we have found the distance of all the cells from nearest zero. So our answer is what? Here I'm only showing that this 0 is helping the unvisited one to fill its value by adding 1 to its value, right? So our answer is this, right? So we are able to find the distance of all the cells from nearest zero by using the complexity of BFS only, right? So what we are doing, we are storing the location of all the zeros in a queue and we are applying the BFS on all the zeros instead of all the ones. So if if any of the unvisited cell is found in the neighbor of this zero, then this zero is helping to fill that unvisited cell by adding 1 to its value. Also, after updating the value, we are adding this location to the queue. Why? Because this is possible that this one is going to now help the any of the other unvisited cell to fill its value, right? So we are going to apply BFS on this also, right? So this is our approach. What we are going to do, we are taking a queue, we are adding the location of all the zeros and mark all other cells as unvisited. Next, all these zeros will help to fill all the unvisited cells. Will apply BFS on all the zeros, right? So this is taking a time complexity of BFS, that is big of V plus A, right? So let's move to the code part now. So we are doing what, that we are traversing in the entire 2D vector, right? So we are traversing in the 2D array. If 0 is present in any of the cell, then what we are doing, that we are adding the location of this cell to our queue, right? So since we are using a queue here, so we have to create a queue and we are adding the both the rows row number as well as the column number. So we can use a pair class where the first value is going to represent the row and the second value is going to represent the column, right? So let's use that pair class. Both the row and column are of integer type and let's name this as pairs, right? So also we need a queue of type pairs. Let's name this as queue, right? So we are, if the value is 0, let me right. So if the value is 0, then make a new pair So a function of this pair class, that is make pair, is used to make a new pair. So pair is equal to make pair of I and j, that is the row and column, and add that pair to the queue, right? But else mark all other cells as unvisited. How? By marking them as -1, right? Mark all other cells are as -1, right? Next, this for loop is going to give us the all the values in the queue. Next, we have to traverse in this queue until the queue become empty, right? So traverse in this queue while right. What we are doing, we are taking one pair from this, that is this cell, and we are traversing in all the directions, all the 4 directions of this cell. Now we can move in 4 directions, that is topward, downward, left and right, right? So when we move in the top direction, what we are doing, we are decrementing the row value, right? In the right direction, we are incrementing the column value. In the down direction, we are incrementing the row value, and in the left direction, we are decrementing the column value. So we are going to create a 2D array of these directions, right? So there are 4 directions, and this 0 column is going to represent the row, and this first column is going to represent the column, right? So we'll store these values here, right? So you can store them in any order, and will traverse in all the 4 directions of a particular location, right? Row and column. So we'll create the new location. How? The new row will be the old row plus the value of this, right? 0th column is representing the row, and new column is the old column plus the value of this. The first column is representing the column value, right? So we'll use a for loop which will go from 0 to 4, right? 0 to 3. So this for loop will traverse in all the 4 directions and will give us the possible 4 directions, right? So while the size is greater than 0, take a pair from the queue present at the front of the queue, right? And then pop this and then remove this pair, since we are visiting this pair, right? The pop function will automatically remove the current element, right? Now this remove pair will consist the row and column value. Now let's create a direction array as we have discussed. Now this directional array is of 2 cross 4 size, right? So let's store the directions here. So you can store them in any order. Right? So here you have to traverse in this direction array. Now our new row will be what? The old row. Now the if this is the pair, then this is the first of this pair and this is the second value of this pair. Now this first value is representing the row, this second value is representing the old column, right? So old row, that is first, plus the new row, that is representing by the 0th column, right? In the similar way, calculate the new column. Right? Now you have to check, you have to move in that cell which is unvisited and which is valid, right? So it is possible that if you are present in this cell, you can move here, you can move here, but these moves are invalid. You have to move in that cell only where which cell is unvisited, that is the value of that cell is -1 and that cell should be valid, right? So we have to check the new dimensions, that the new row should be greater than or equal to 0, and new column should also be greater than equal to 0, and new row should be less than the total number of rows present in the matrix, and new column also must be less than the total number of columns present in the matrix. And there should be that cell should be unvisited, right? So the value present at that cell should be -1. If all these conditions are true, then what we have to do? For example, you are in this cell, right? So when you move here firstly -1 is present. So what you are doing? You are updating the value of this cell by adding 1 to your value, right? To the old row and old column value, add 1 and update the value of new row and new column, right? So update the value of new row and new column to the value present at old row, that is, and old column, that is +1, right? Next, what we were doing, that we are adding the location of this also to the queue. Why? Because it is possible that this one should can now help any other unvisited cell to update its value, right? So make a new pair. New pair is equal to use make pair function, add new row and new column to this, and add this to the queue. Queue dot push new pair, right? So you have to do this until your queue becomes empty. In the end, you have to return the vector. Since the return type of this function is vector, so you have to return the updated vector, right? So this is the code. I think this is correct. So let's try to run this and check. So there is one error, that the directional array is of type integer, right? Again one error, that, sorry, by mistake I have put a closing bracket here. Again one error in the directional array. This array is of size 4, 2. By mistake I have wrote here 2, 4. Since there are 4 rows and 2 columns, right? This is 4 rows and there are 4 rows and 2 columns, right? So I think the rest is correct. Oh, here also we have taken the name of the queue as queue, right? Right. So let's try to submit it now. So our code gets submitted. Let's try to submit it for all the test cases. So our code is correct for all the test cases, right? So what we are doing, that we are traversing in the entire 2D matrix. If 0 is present here, we are adding the dimensions of those 0, that is the row and the column, to a queue, right? If 1 is present here, we mark that cell as unvisited by converting it to -1, right? Next, after filling the queue, what we are doing, that we are traversing in the queue and we are applying the BFS on all the cells, right, where 0 is present. So we are applying it in all the 4 directions. If any unvisited cell is present in the BFS, then what we are doing, that we are updating the value of that unvisited cell to the actual answer and adding that unvisited cell also to the queue, because it is possible that now that cell is going to help to update any other value, that is to find the answer of any other cell, right? So we are making a queue and we are traversing the queue until the queue is empty, and we are updating the value of unvisited cells, right? In the end, we are returning the updated matrix, right? So this is the code and this is the problem. I hope the problem is clear to you. So if you like the content, give a like to this video. Thank you for watching.